A. Rucker. He is going to be delivering a presentation on the VCRB Hypothesis explains the image formation and the carbon dating. He earned an MS degree in nuclear engineering from the University of Michigan and professional engineering certificates in nuclear engineering and in mechanical engineering. He worked 38 years in the nuclear industry performing nuclear analysis, computer calculations for the design of nuclear reactors, critical safety analysis, and statistical analysis of experimental measurements. Since 2013, Bob has been doing research and presentations on the Shroud of Turin and has written 39 papers, including papers 33 and 34 to explain the carbon dating and image formation. They are found available on the research page of his website, www.shroudresearch.net. Bob Rucker.
Thank you. Thank you.
Thank you.
When scientists are trying to solve understand the problems associated with a phenomenon, what they do is that they take in all the evidence that they know and from various sources, hunches, speculations, any knowledge that they have, analogies, for example, with other information. They put together a hypothesis. Now, a hypothesis is not a claim that their concept is true. It's a claim that it could be true. That's what it is. So that a hypothesis must be consistent with all the evidence to be true. It should make predictions that are testable and falsifiable. That is, when you do the test, it should be capable of proving the prediction wrong. And that would then falsify the hypothesis, at least as formulated. And then there's a kind of what I call a third category here of things that scientists would like to see. It's recommended, for example, that a hypothesis explain multiple mysteries of a phenomenon. And so that's why I think it should be regarded as attractive for scientists to see that the VCRB hypothesis explains two different mysteries. I think probably the two main mysteries of the Shroud of Turin, image formation and carbon dating. That would be very attractive to scientists. Now, VCRB you have to have an acronym, right? To be serious about it, you have to have acronyms. So VCRB stands for vertically collimated radiation burst. Collimated means all going in the same direction, like a laser beam. The photons in a laser beam are all collimated. They're not going like this. They're going up and down. So that's what we're talking about, okay? Yeah, so I am now down on item 3 here, VCRB hypothesis, and then we have a number 4 coming up next for me. I'm not sure, I don't think it's the next hour, but soon. So options to be rejected, I would include this on image formation. Image formation is not by an artist or forger, it's not by pigment, scorched liquid, or photography. According to Stirp, and all attempts to duplicate images have failed. Sometimes people show, well, this is similar. Well, similar is not identical. All it does is it proves how you can't do it. Every time they propose that, it's just another way that they can't do it. And it's not by contact, because the images, there are images where the cloth was not in contact with the body, such as the cloth would not have been in contact with the nostrils, yet the image is there. Many other locations as well. And it's not by random motion of molecules, because random motion of the molecules, in a random motion of molecules, there's a random path of the molecules. And so random means that they're always scattering in a random location so that they are incapable of communicating information, which is absolutely necessary to form an image. Every time you see an image, it's formed by information. so that you can see me, I can see you, because of reflected photons carry the information from my body to your eyes, and vice versa, okay? So, and it's also, I think it's important to add that the image on the shroud is unlikely by any natural, that is normal, process. Billions of people have lived and died. They've lived wearing clothing for the most part, and they've died often being buried in a cloth while sick, or not covered with a cloth while sick, and maybe buried in a cloth after they died. Yet there's only one example of an image of the person that it covered. Now, I give you permission. This is safe to do. I allow you to do an experiment. Go home, look through your closet and your dresser and see if any of your clothing have an image of your body on the inside. Okay? Simple experiment. Okay?
I had a sheet in college that I had that happen to me after I didn't wash it for about a month.
There. Okay. Well, with one other exception. There you go. Okay. So the main radiation hypotheses here, we have the cloth collapse hypothesis. I deal with that in my paper number 14 on shroudresearch.net. And then there's the holy fire, or previously called the corona discharge hypothesis. There's the UV hypothesis based on ultraviolet laser experiments. And then there's my concept of vertical collimated radiation burst hypothesis, which is my paper 34 on shroudresearch.net. So let me just read you the definition of what I'm going to give you. A VCRB hypothesis for image formation. A high-frequency vertical oscillation of the atoms, actually nuclei, in Jesus' dead body was so powerful that it caused deuterium nuclei in his body to split, i.e. to fission. This released an extremely brief, intense burst of protons to be emitted that rapidly oscillated up and down. This caused an oscillating corona discharge from the top fibers that caused a high-frequency alternating current in the fibers that deposited heat in a thin layer around the circumference of the fibers. This heat scorched the thin layer to form the images. So in other words, I'm rejecting chemical changes as causing the discoloration. I'm rejecting radiation damage as causing the discoloration. I'm saying that electrically deposited heat scorched the thin region. So it's a scorch. And that's why the color is a scorch. That makes good sense, doesn't it? Here's the criteria that I mentioned before. A good hypothesis must be consistent with all the evidence, not just some. And therefore, when other hypotheses for image formation start with a concept and they work down from that, I'm starting from the evidence and working up from that. Totally different approach to solving the problem. It must be consistent with all the evidence. It should make predictions that are testable and falsifiable. It's preferred if the hypothesis explains multiple mysteries, is simple. We can discuss that further, exactly what that means. Is corroborated by diverse areas of study. And you know, I think this is an important item because we actually do have a diverse area of study. That's Scripture, Christian theology. That's a diverse area of study. So it has beauty sometimes. That's difficult to define, though. I mean, not for me. We'll talk to my wife about that later. But okay. So the other thing maybe I should mention, in this particular case, it explains how information was communicated from the body to the cloth to form the images. That's necessary when you're talking about an image being formed. Where is the information coming from? How was it transported? How was it communicated? So, objections to the VCRB hypothesis. Discoloration by radiation damage? No, I'm not assuming that. Usually I find that when people object to what I'm saying, they're misunderstanding it in some way because they're hearing what I'm saying in light of their own presuppositions. So I have to, and that's why we have questions afterwards. Okay, and so the requirements, next objection would be requirements for the energy level. This is a difficult issue. A maximum air gap distance of about 4 centimeters is present on the shroud. If there's a gap larger than about 3.5 to 4 centimeters between the body and the cloth, then there's no discoloration to image any part of the body. So the radiation would only go that far. Okay, there's no additional ion tracks in the image fibers compared to the non-image fibers. That's an observation. The image fibers have about the same density of ion tracks as the non-image fibers. How do you explain that? If you're going with a high energy electromagnetic energy or particles, then they're going to cause additional ion tracks in the image fibers. So what are we saying here? What we're saying here is that the energy level of these particles has to be very low, below the threshold necessary to cause an image track. So let me just go through here quickly. I want to get to the carbon dating now. We're just doing a little bit here on image formation. And I'd like to just contrast the ultraviolet light hypothesis with the VCRB hypothesis. So the type of radiation, ultraviolet light versus protons, but not neutrons. Sometimes there's confusion thinking I'm saying that neutrons cause the image. I'm not. Neutrons are highly penetrating, and if they were to form the image on the inside of the cloth, they'd form just as strong of an image on the outside of the cloth, which is contrary to the evidence. So the images were not formed by neutrons. So the method of analysis, top-down based on laser experiments for the UV hypothesis, bottom-up based on 27 evidences from the images that I use, consider one by one, to allow the evidence to bubble up from the evidence to the cause. Is it consistent with all the evidence? Well, in the UV hypothesis, it should make additional ion tracks in the image fibers. That's a difficulty. How do you explain it in a way that it apparently is not? And so in my VCRB hypothesis, yes, it passes that test. And I don't know of any other mechanism that passes this test, because this is a brand new mechanism that I'm hypothesizing, and that is in the skin effect of an alternating current. You can look that up under those words, skin effect of an alternating current. Look that up on Wikipedia. It's a standard part of knowledge of electricity. Okay? And what it says is that an alternating current in a conductor will cause oscillating electric and magnetic fields which force the electron flow to the outer radius of the conductor, exactly where the fibers are discolored. So that's why I'm using that in my hypothesis. Well, does it explain multiple mysteries? UV hypothesis, no. VCRB hypothesis, yes. Mine explains carbon dating. Radiation has a vertical orientation. HV hypothesis, yes, I believe he adopts that. He's good with that. And mine says yes as well. Cause of discoloration in the HV hypothesis, it's radiation damage. And in my hypothesis, it's alternating current causes electrically deposited heat in the fibers. So why only the circumference of the fibers is discolored? In the UV hypothesis, the surface layer had a different composition than the inside fibers. He has to resort to a different composition because there's plenty of energy in these ultraviolet light photons to be far above the threshold for making ion tracks. Whereas I'm saying in my hypothesis, the heat only scorches the circumference of the fibers. And you can actually determine the frequency of the alternating current in the fibers by considering the thermal and electrical properties in the fibers compared to the thickness of the discoloration layer. I haven't done that calculation yet. So the VCRB hypothesis also explains the carbon dating of the shroud. Let's get to the good stuff now. Okay? So again, you've seen this. This is all the data that we have. The green values are the values reported in Damon. The red values are my values, assuming a Gaussian or normal distribution. Okay, so we actually have 4 types of carbon dating evidence. Think about it. At the bottom, we have the average value uncorrected. I'm going to use this all uncorrected. You know, we're not going to, the bottom line number is 1260 plus or minus 31, which is then corrected for the changing carbon-14 concentration in the atmosphere to a range of 1260 to 1390. But since the dates up above are all uncorrected, let me use the uncorrected values of 1260 plus or minus 31. Okay, so that we have the 1260 plus or minus 31, that's the mean or average value. But then we also have additional evidence here, so that we have the dates from Zurich, Oxford, and Tucson laboratories, the average for the laboratories. They were slightly different, right next to each other, but slightly different location. So that gives us a gradient, a slope or a gradient of this carbon dating evidence. So we have the mean or average value. The statistical analysis people use the word mean. In a normal layman, we'd use the word average. Okay? So that's why I'm saying both. But the 3 different laboratory average values would then give you the slope or gradient of the data as a function of the distance from the short end of the cloth. But then you also have the 12 different values for the subsamples, the range and the distribution. Now, why isn't it that everyone is trying to compare with that data before we get down to the statistical analysis? I mean, that's the better data to try and fit to, right? That makes sense. Use the best data you have before you start the statistical analysis. So that one of the best ways to deceive people is to give them a little bit of truth, but not the whole truth. So when they say the shroud was carbon dated to 1260 to 1390, ask, what's the rest of the story? And so we don't just have one value, one evidence from carbon dating. We have 4. And science has to be consistent with all 4 types of data. If it's not true. Okay? So one type of data is the mean or average. Then we have the slope due to the laboratory average values. And then we have the range and distribution of the 12 subsamples. And then the 4th value is down below, the mean carbon date for the Sudarium of Oviedo, believed to be the face cloth of Jesus, mentioned in John 20, is about 700 AD. It was tested 3 times, and I think the range was about 660 to 740 or something. And Caesar Barta would be the reference on that. So that we have 4 different types of evidence on carbon dating, and the correct answer has to be consistent with all of them. Okay, so where we left off with my last presentation over in the other building, I had checked off 1, the mean value, 2, the slope or gradient. I left a question mark on range and distribution, but I also checked off the carbon date for the face cloth. That's where we were up until I started, restarted my nuclear calculations about 5 months ago. It's quite an effort to do that. That's why I hadn't been doing calculations from 2015 up to 2024. So now there's 2 problems with trying to calculate using my computer code, MCNP, to try and calculate values that are consistent with the range and distribution of the measured values. There's two problems in that. First of all, when these samples went to Oxford, Zurich, and Tucson, each of them cut their one sample into subsamples. But did they record that, how they did it? Did they video it? Did they tell us? No. So I had to go through and try and reason it out. Now, talking with other people, they said, oh, well, that's useless. There's over 280,000 different options. Well, all I need is one. All I need is the right one. Right? It's like playing a game of chess. All you need is the best move. You only need one, right? Each time you only need one. So you can play chess and still win against a master if you make the right moves. So that's what we have to do. Now, there's various types of information that's available to us to help us to sort out how the samples were cut into their subsamples. First of all, there is the designation that the laboratory used to designate the subsample. For example, O for Oxford, O 1.2, B, and then there's O 1.1, U, and O 1.1, B. So what happened was that it was first cut horizontally so that we have 1.1 below the line, 1.2 above the line. Then 1.1 was cut in half. So you can get the sequence of the cuts, okay, from the labels that were given to us. Second information that we have is that we have the carbon dates and the uncertainties. So that you notice in the black, I have the carbon dates. See if I can do this. That's not working. Okay, we'll talk about it anyway. So what we have is you see from the right to the left, the carbon dates are going down. Okay, and conversely, from the left to the right, they're going up. Okay, so now both on the top and the bottom, they're in sequence, because I not only had the carbon dates, but I had a good theory to explain them. And the concept to explain them is the neutron distributions in the tomb calculated by my computer code. Because I think that the carbon dates are varying by the neutron distribution in the tomb, because the neutron distribution was causing nitrogen-14 to produce new carbon-14 atoms as a function of the neutron distribution in the tomb. So if we had the body laying out here, you have the head down here, middle of the body is here, the neutron distribution, and I'll just indicate the magnitude of the neutron distribution would come up, peak over the center of the body, and then come down like this, like a cosine shape, only it's a little bit shifted because the body is not uniform. Okay, it's not just a rectangle all the way down. It goes smaller here, so it tails off a little bit slower down here. So, but it also, from the body, it comes down like this from the body as you increase the distance from the center of the body. Comes down like this. And so when I first started considering this was when I read the Damon, the paper on carbon dating in the back room of the library, probably about 1993, and I said, aha, I think I understand what's going on here and why the shroud is still authentic even though it carbon dated to 1260 to 1390. But I couldn't do a thing about it because I was so busy and my computer was not fast enough, and the computer code was not adequate to do the calculations. I had to wait 20 years for those things to be resolved till I had enough time, my computer was fast enough, and the computer code was exactly what I needed. And so what we see here, for example, do we have another pointer I could use? Whoops. I don't have anything.
Was it working before?
I don't know.
Let me see.
So we don't have another one.
There. It's the middle button.
It's the
Yeah. You're wanting to point?
I wanted to point.
Oh, I didn't know. I'm sorry. All right. I'm going to go find it.
Yes, okay. Okay, so what we have here, for example, if you take for Oxford, and you average the two at the bottom, and then you take the ratio of the top to that average, you get a certain value, about 1.075 or something. And if you take region 3 and 10 and do the same thing there, you get the same ratio. Okay? So that's why I line them up this way. So that regions 2, if you take the average of 8 and 9, take the ratio of region 2 to the average there between 8 and 9, you get a lower value. Let's say it's about 1.4. Over on Tucson, if you do the same thing there, you get the same ratio, about 1.4.
He's saying that your slides won't allow that, but you could use your mouse as a pointer if you want.
Oh, okay. Okay. So maybe I'm... see anything. Okay, let me go on. So that's what we have here. And you notice on this diagram, on the lower left-hand corner, it's 0, 0, and I'm just indicating the length of items on this little sample that was cut from the shroud. You know, it was cut about that long. It was then cut in half, and then this was cut into 3 parts to send to the 3 different laboratories. So it's only about 3.8 centimeters long by 1.6 centimeters high. That's all it is, you know, inch and a half long or so. So it's relatively small. But let me call this a region, okay? So one problem was that we were not told, we didn't know how the subsamples were cut from the samples. So I'm proposing this is how it was done. The second thing that we're not told is that the little piece that was cut into the 3 different samples, where was that at the moment of Jesus' resurrection? Okay? Was it out full distance? Or was it tucked up under the center line of the body? Was it somewhere in between? There's some evidence, for example, the cloth maybe wasn't on the face, but it was elevated above the face, maybe that went on down, maybe. So that maybe the cloth was elevated above the body, even. So I had to run options. And that's how, with my computer code, if there's an uncertainty on energy or direction or whatever, I have to bracket all reasonable options calculationally. So what I did was I took this region here, including all 12 subsamples that were dated. Let me call that the region, the large region, so that I had to model these large regions in my computer code multiple times at different locations. So I set it out in an array of 3 in the x direction, 7 in the y direction, and 4 in the z direction, because I thought maybe it's elevated. So that gave me actually 81 different locations where I modeled this large region in my computer code. And so then I looked through all the results to try and find which agreed best with the measurements, thus indicating where it was actually located at the instant of resurrection. That's the purpose for this. And most of them was not good, not a good comparison. But I could see that right up near the center line, as though if the body was laying here and the person down at the bottom took the excess cloth and just went like that and bringing the excess cloth up underneath maybe the legs, for example, that would be a possibility. And so what I saw in the results, that as you increase the X value along the backbone of the body, if you increase the X value, it gets better and better. The Y value didn't matter, the Z value didn't matter, but it was the X value. But I only had three locations in the X direction. So this was just the first iteration I'm going to show you. So there's going to be a second iteration. I'm going to learn a little bit more, and maybe a third iteration. Okay? Because I'm not satisfied entirely with the results. Now it's not working at all. Can we? Okay, I just turned it off. No. Can I just move something? Can I push something?
Usually works, but it doesn't either.
Okay.
The keyboard don't works. The keyboard don't work.
I'm not sure what I...
Working with this, huh?
Hmm?
Let me see what I can do to help you out.
Yeah, where are we? It just doesn't seem to work here.
These slides loaded a little differently than. Here's your mouse right here.
Yeah, okay. Because it wasn't moving before.
Oh, okay. Yeah, see, you can use this as a pointer.
Yes,
right
okay.
here.
Yeah, but I can't advance that. That doesn't work.
Without what
Yeah, I don't think it died.
I have to get to the next slide.
Yeah.
That's the important one.
Yeah, let me
Tried
plug this
using
thing in real quick.
the pad too, and I couldn't get it to go.
So do you understand why I'm proposing that this is how the samples were cut into the subsamples? It just makes sense, and it made sense to me. And I said the ultimate proof is in the comparison with my calculated values. Can I calculate it if it's divided this way?
Let me hop in here real quick.
Can you just ask the way you got it set up there, is there any chance that the Oxford folks had a 1.2A that they threw away?
I'm not aware of it.
Because they got a 1.1U, a 1.1B, and a 1.2B. I don't think there's a 1.2U. I said, hey.
Yes,
I meant
you know, I'd like to get more information that could be factored into this. For example, if anyone knows the weights of these subsamples, I'd like to know that, because then that would change maybe where my cut points are that I'm assuming here. Okay, so there's probably some more information that I could factor into this.
What energy are you assigning the neutrons in MCMB? What energy are you assigning the neutrons?
Yes, the threshold for forming the ion tracks is about 10 to 30 eV. I'm assuming 3 eV at this point. Later calculation, again, I'll bracket reasonable values. I can bracket reasonable values with my calculations.
And do we have a pointer?
Yep, you'll just have to use the mouse, so we're good.
Okay, but does it go forward?
Yep.
Yeah.
Okay, so now let me, so this is my drawing of how my model was made up as recommended by Lean Rittmeyer, Israeli archaeologist. And the important point here, you have the door, we have the door in the front here. This would be the door. We have a side bench, left side, right side bench with a back bench. I'm putting the body on the back bench with the head to the right, but then these are walls around that are cut back in order to let us look inside here. And you notice I have the face cloth here in the diagram that I put, and I'll discuss that in just a minute. So let me give you the model that I'm using here. So the pink is the body, the off-white is air, the gray is limestone. So this is a top view in my model. This is actually produced by my MCNP computer code, utilizing another code to access the MCNP data. Okay, and so this is an XY view, so that we, you know, the horizontal axis here is X. You know, they'll be in the direction of the center line of the body, and then we have Y, which is perpendicular to it. So this is looking down on the top view of the body. The body is modeled with very simplistic cuboids, one for the head, one for the body, arms wrapped together, and two separate for the legs and for the feet. And so that's what that looks like. The limestone to the right. I'm not showing all the limestone here. I'm showing more of the limestone. Here I have 1 meter of limestone on the floor, the ceiling, the walls, and a significant limestone for the shelf. But you see on the back here is the body, and this is just a cut through the middle of the body showing the feet down at this location. So this is a side view then. This is the body, a rectangular body with rectangular linen cloth around it in a box shape, open at the feet. So that this is the side wall, this is the ceiling, this is the floor, this is the limestone shelf, this is the rolling stone out in front, this is the entrance through the front wall. So that is the YZ view. Okay, so that if we focus in here on the feet, this shows the linen cloth, a very thin linen cloth. Of course, the shroud is about the thickness of a man's t-shirt, very thin. Okay, that's another reason why you can't believe the invisible reweave. You can't reweave such a thing invisibly. Oops. Okay, so these regions that I'm talking about, which is the configuration of the 12 different subsamples. So I'm modeling 3 of those in the x direction, 1, 2, and 3. And then you notice here, I have one level. There's another level here that's right at that point it's interfered with the feet, so I'm not including that. And then there's 3 and there's 4. That's the 4th highest region, just in case there was an elevation due to electrostatic effects. But you can see that all of these, so the feet would be here, and we have a short distance from the feet to the wall. That's important because neutrons are going to be returned from the wall. So we have another peak coming back from the wall. So that as we move forward here, this is looking at it from the other direction, so that we have the both legs. This is a YZ view, and this shows these different, what I call tally regions, because that's where we're counting things. They're called tally regions. That makes sense. But you notice, so I have the bottom level here right on the limestone. Then I have about the same distance each time coming up. So this is the body. This is actually the linen cloth around the body. So when you get down to where the feet are, it's quite a bit outside. But I have to do that just for simplicity to make this thing work at all. So we have a top view here showing the 3 different large regions in the x direction, the 7 regions in the y direction, and each one of these large regions is what I showed you before as to how they cut the 3 samples into subsamples. Okay? Now, so that what I'm labeling here, this is region 371 that I'm showing. So the 3 relates to the x value. So this would be x equal 1, x equal 2, x equal 3. The 7 is related to the y value, and then the 1 is related to the z value. So each one of these large regions I designate with a 3-digit number. Okay? So this is the results. Now, what we show here, again, with the black values, you notice, let's just look at the 2 corners, first of all. So we have 1355 is the measured value, plus or minus 30. I have 1356 is the calculated value. Wow, that's pretty good. No, so you look down at the other corner, not quite so good. 1155, and I calculated 1196. So that the range of the values goes from the smallest to the largest, 1155 to 1356. There's 209 years range from the 3 different corners, whereas my calculation is 160. Now, I mentioned to you that this is just the first iteration. So I've learned something. I have to move it a little bit further up in the x direction. Okay? And I think we'll see. We'll see how it turns out best. So the slope in this direction is good, but the slope in this direction is a little bit off. And you can see that here. For example, these values are a little bit, especially that one, is just a little bit large here. This is a little bit large, a little bit larger, a little bit larger, and these are a little bit larger. So we'll have to see exactly where I find a better match between the calculation and prediction, assuming that these carbon dates are produced by their measurement of the new carbon-14 produced by neutron absorption in nitrogen-14, as well as including the carbon-14 on the cloth itself.
What was
So
the number of source neutrons?
the number of source neutrons in 20 days was somewhere between 2 to 3 trillion. Is what I utilized in my calculations.
Yeah, not the number of particles,
Okay.
the number of neutrons.
Okay, number of neutrons that were used to would be used to produce this.
To create the reactions.
Yes, okay, understand. So that I can calculate these changes in carbon dates from 33 AD to these values by an emission from the body of 2 times 10 to the 18th neutrons. In other words, it's 2 followed by 18 zeros.
Is that integrated over the entire body, or is that per emission region?
No, that's homogenized over the entire body. So that's a total emitted. So the question is that a large number? 2 followed by 18 zeros. Well, it depends on what you're comparing it to, right? So how many neutrons are in a human body of 175 pounds? Because it's been estimated that the weight of the body is somewhere in the range of 170 to 175 pounds. So I chose 175 pounds, calculated it. And, you know, it's not a difficult calculation because you can look up the weight fractions of a human body. And so that tells you how to do the calculation. So when I do that, the total number of neutrons in a human body of 175 pounds is about 2 times 10 to the 28th neutrons. So it's 2 followed by 28 zeros. So the ratio between those indicates that this is only an emission of 1 neutron per 10 billion in the body. So in other words, this is a very small effect. The major effect is the disappearance of the atoms that were in Jesus' body. This is a small effect.
So are you constraining the neutrons to move at 90 degrees to the body?
You know, I can assume it to be anything I want. I define.
But what did you
I
specify?
define. Let me just think on what I did here. It's not too important what I did because as they go through the body, they scatter off the elements in the body, and so they forget their initial direction anyway. But I'm just thinking here, what I think I did was that I assumed that they were vertically oriented.
And we need to realize we only have about 12 minutes left.
Yes, okay. Yes.
And you modeled the body as 175-pound body length?
Yes, 5'10", 175 pounds. Okay. So I talked about the range being a little bit off. We need another iteration on this calculation. But let me talk about the distribution. Now, you should not be too impressed that all these values are about the same, because all the black values, the average for all the black values, as calculated by Damon, was 1260, plus or minus 31 years. So I took the red values, I had to normalize them to something, because when the computer prints out the data, it's normalizing everything to 1 neutron. Wow. We're not talking about 1 neutron here. We're talking about 2 times 10 to the 18th neutrons. Okay, so I had to normalize there. And what did I normalize to? I normalized to the same thing as the measured values. So the average for both the black and the red is identical. So I'm not taking credit for that because I forced that to be the same. So I normalized the red values to be 1260. Okay, so I'm not taking credit for that. But what I am taking consideration of is how well it fits the range, it's a little bit off there, and the distribution, so that we can calculate how good the distribution is by a chi-squared calculation on this, where you take each difference and you square it and then you add up all the values. And so
These are just reflecting the neutron to carbon reaction only, right? Because there's many other reactions going on. You're just selecting just those, right?
yeah, I did. See, there's actually 3 different reactions that can form carbon-14 by a nuclear process. One is carbon-13 absorbs a neutron, goes to carbon-14. Very small, okay? The next is what I used, which is nitrogen-14 absorbs a neutron, produces a carbon-14. And the third is oxygen absorbs a neutron and results in carbon-14 when it emits an alpha or helium-4 nucleus.
That won't happen for a 3 eV neutron, though.
Yeah.
Not enough energy.
Not enough. Okay, that's fine. So anyway, the result, I think, from the previous calculations was that the nitrogen-14 reaction absorbing neutrons gives you 96% of the total effect. So I'm just considering that. Later calculations, I'll probably include the other 2 as well. Okay.
And the source term was the entire volume of the body was emitting neutrons, or just off the skin, or how did you release
Can we
the
hold
neutrons?
questions until the end, please?
Okay. Yes. So the distribution here looks actually very good. For example, down across the top, it's very good. Not quite as good across the bottom, because the neutron distribution this way is not quite right, because the location of this large region is not quite right So that goes into the next iteration to find where it's more likely to have been located at that point. Now over on the left here, I show the different designations. 111 is x of 1, y of 1, z of 1. And then in the far corners, what I showed you before is the 371, which would be the x value of 3, the y value of 7, and the z value of 1. So what I'm showing you here in groups, for example, this group belongs to this large region. This information belongs to this, and this region over here, this data belongs to this. So what I'm showing you here is the range and the chi-squared value to show you how close we are, because the range was 204, but you notice that I'm at 160 here, and nothing else is close to 160. This is close to the center line of the body, is the only place where the data gets good. Okay, so you notice here, 129, 139, 160. Well, I'm searching for 204, so it's up further in this direction, in the x direction. That's be the next iteration. Okay, and we have the chi-squared value. Look how far the chi-square up here would be 0.802, and the best was over here at 0.394. This is significantly better than if I were to assume that all the cloth was manufactured in 1260 and that the carbon dates of all of them were 1260. This actually gives you a better fit to the data significantly better than the medieval reweave or medieval date of the shroud. Okay? And that's an argument. This is the data in the carbon dating is much better fit by neutrons being emitted from the body than by assuming a medieval date for the shroud. Not interesting. And so I think maybe another 2 or 3 rows here in the x direction might be sufficient. I'll probably include some possibility of z direction as well. But that's just how I'm doing this. Okay? Okay, so these are the locations of the x values, the y values, and the z values. Boy, yes, okay. And so if we again consider the invisible reweave, where the yellow is the old material, 33 AD, and then the orange is about 1520, the result is that none of the subsample dates are within the range of the measurements. None of them are. Isn't that interesting? Do you understand what I'm saying? So that, for example, this is all new material. All of these are all new material. We only get a mixture down here, and when we get a mixture between the new and the old material, I calculated the value based upon the heights of the new and the old material. But all of these are above 1155, or below 1155, and all of these are above 1356. So that none of them are within the range of the measured values. So we need to get away from referring to the invisible reweave. It's only confusing people, and it cannot be true, at least as it's been communicated in the past. Range and distribution of the image formation hypothesis. Let me just stop there, okay? Let's go to questions. Yes, Tom.
This goes back to your idea that the radiation burst hit the fabric.
Yes.
It seems to me when that happens, the electric current could go down the whole fiber, and it could damage potentially the whole fiber depending on the energy. It wouldn't be that difficult to calculate, make a model of a cylinder that was having the conduction on the outside and just see how far down the energy goes and whether it only goes a short distance compared to a longer distance. That, you know, the distance you want to see is what's in the shroud.
Yes, of
Have
course.
you thought about doing that type of model?
Well, you know, what I'm talking about here is neutron absorption.
I'll go back to your other.
Okay, the image formation, I noticed that. I just want people to recognize what you're talking about. So you're talking about the protons, not neutrons, but protons.
Generating the current.
Then hitting the fabric and generating a current to flow in the fabric. And yes, we need to do that. There are many different concepts, many different questions, many different areas of investigation as to how the electricity is being conducted in the fabric and where the electrostatic charges are building up and the corona discharges are occurring. There's lots more to be done.
People must have modeled that. Take an infinite cylinder and look at conduction on the outside of the cylinder.
Yes.
And just calculate energy distributions and just, I would imagine somebody, you can probably find something like that.
I'll talk to some of my friends on that, okay? Yes?
I can hardly believe I'm saying this, but the resurrection occurred in the Holy Sepulchre, correct?
99% probability.
Okay, and it's the protons and whatever electrons that is generating the image. We don't really worry about the neutrons on that part of it. Okay, but the Holy Sepulchre, when you read about it, it's an electric field that is igniting the fire every year that's been going on for over 1,000 years. So if Jesus is in this place and the electric field occurs, that would explain the verticality of the image on the shroud, which I've tried to wrestle with for years. And so anyway, this may be the result of being here for 3 days and your brain begins to turn to mush. Or it may be, if you acknowledge that miracle, and with electric fields up and down, that could help with that, understanding that process.
Would you allow me to think about that further?
Yes.
Okay, good.
All right, are you done?
Yes.
How would you respond to a potential critical response saying that you might be baking in circular reasoning because you presupposed how they cut based off of your model,
Yes.
predicting where the cuts would be, and now you find good correlation across the cuts with the data. Is that not circular reasoning?
I'm anticipating that as an objection, okay? And we're going to have to think about that. Yeah, because there's always going to be objections, right? When the bombers left England, they could tell when they were over the German cities by the flak they were receiving. So we're not surprised. Yes?
Two quick things. In your last talk, you mentioned there was a high carbon monoxide content. Can you tell me, have any idea where that came from?
That's not my theory. That's John Jackson's theory.
Okay.
Okay, so I don't go there.
Okay. The other.
One last thing.
Another part to that is that no one has ever thought about the fact that everything you're talking about is part of the electromagnetic spectrum, and eternal properties cannot have that.
Talk to me afterwards about that, okay?
I think we're going to have to cut it short. Let's give them a hand, guys.